Today we're looking at how we understand engineering drawings. We're not going to go over how we necessarily create them fully, but we're going to look at how we read them, what the purpose is, and then we're going to also be able to make some parts in Onshape based on drawings. Okay, so why do we actually have drawings? Why do we need drawings? Kind of why are they part of our the flow to making parts? So what engineering drawings specifically do is they allow us to communicate the size and features of a part very specifically. So instead of just having the model like we do over in this right hand column, um, it'd be very hard to actually produce this with just this amount of information. We don't necessarily know the scale. We don't know a lot of things. Like if we have the model, you can sit there and you can use your CAD program to get the different dimensions, and that works. But it's very difficult to just make a part from the model if we're doing it, if a human is doing it. So if we were 3D printing this part, if we were making it on a computer controlled machine, we can have the entire 3D model and we can provide it a file that works and has all those dimensions and things in it. But for humans, it's much easier to have something where we can read and we can look at all the dimensions and we can understand the part. They also help us check the part. So even if we do produce something with a computer controlled part, we can take measuring devices and actually check that the part was created properly. Um, and it's very useful to provide information for anyone who's going to make the part. So if you're designing a part, or you're working on some subsystem, and someone's going to make a part for you on the lathe or the router or whatever, having that drawing can tell them all sorts of things like how many to make, any specific call outs you want, notes, all of that stuff can be documented and they can make the part properly without having to make assumptions about what you want. So as a designer, it's really important to produce the drawings properly so that whoever is making it, machinist, our sponsors, some other member of the team, whatever is happening, they're going to make that part correctly. So both parties really want to be have a lot of incentive to make sure the drawing is accurate and communicates the information properly. We're going to spend most of the time on talking about how we actually read the drawing, not how you actually produce it. At the end, there's a tutorial on how to do that in Onshape that you can watch. It does a really good job. We don't need to do that here. We'll probably do it at a future date once we do get a lot more into, we have a little bit more experience designing parts as well. Okay, so this is an example drawing of this same part. This was a part from our 2020 robot. This was a bumper mount. It was a sheet metal part. So it started as a flat piece of sheet that gets cut out and bent. So we produced the drawing to show our sponsor Solarcraft how the bends get made. They also know how many they're made and which way the bends are. So we provide a lot of information to how this part's going to actually be produced through the drawing. So this is the drawing. We have a lot of information on here. We're not going to go through all of it at the moment. There's a lot of things you don't necessarily need to know how it works right now. But we're going to go through some of it and kind of look at how it helps us and what information it provides. So looking at this drawing, the first thing you can tell is there's several different what are called views of the part. So this view kind of looks exactly like just the 3D model looks. And then you have these other views as well. So it's important to kind of figure out how do all these relate to each other. And the way they do that in North America, the UK, Australia, a few other countries all do it the same way. There's some other places that do it differently, but we're all going to learn it this way because we're in America. And it's called third angle projection. So almost every drawing you see will always be this way. You don't need to worry about the other way unless you move to some parts of Europe, other places like that. So the idea is that the part that we have is basically like inside of a box, and the drawings are as if we're walking around and looking at different views of it. So in this diagram here, the box basically unfolds, and you can start seeing the different views. So we have this front view, and it stays in the same place, and so it's looking at it like as if you're looking directly forward, and we can see all the lines that are represented by that part. And then we have this view over here on the right side, and it's as if we were standing and looking at the right side of the part. Same with this view on the top. Then you also have your left, bottom, and rear views as well. For us, most of the time, the vast majority of our drawings, we're going to default to having this front view, this right side view, and this top view. There are parts where this doesn't necessarily make sense. Maybe there's a very specific feature you can only see on the bottom or you can only see on the left. So sometimes you will add these other views. But most of the time we do a 3-view drawing for a lot of our parts, and it's just these 3 views right here. So looking at this, that's what we're looking at here. We have this front view, side view, and top view. Okay, so we do have some names for these. It's not super important that you know exactly how these are, but they'll help when you do start making the views on how we produce them. The first view that we look at, this is normally the front view, is called the base view. It doesn't have to be the actual front of the part, right? The part can be rotated in any way. It doesn't necessarily depict how it's going to be mounted in the robot at all. This whole part is on its side here in the drawing, and that's fine. But for our purposes, we're going to call this the front. This is the top, so we can tell that this is what it would be like if we kind of spun this part and had it looking now at the top. And then this view from the side is the same thing, except we're going to be looking at it from the right side. Up in the corner, this 3D view where you have, it's clearly still able to be printed on a 2D piece of paper. So it's just from a different perspective. It's called isometric. So it's basically if you were looking at like the corner of a cube, you would have this isometric view. So this front view would be one face, the right view would be another face, and this top view would be here. And the isometric view allows us to kind of see the part in 3D, and we can kind of use this to get a better mental image of how this part actually looks based on all of these other views. If you didn't have this, sometimes it's a little tricky to see exactly how the geometry would be. One of the challenges you'll do, like if you ever take a drafting class or something, a lot of times they'll give you these 3 views and have you draw the isometric view, or they'll give you the isometric view and have you draw one of these other views, because you most times have enough information to get a reasonable approximation of the other views. Okay. Another part of the drawing that's really important, especially for us on the team, when we're making a part that another team member is going to make, or Solarcraft, we want to make sure we're providing notes that they can use to help them know exactly what their actual task is, right? Just telling them how the part's made or what the part looks like isn't always enough. So the notes section allows us to have a lot more information for them, especially in like quantities and produce and things. That's not necessarily the best engineering practice if you go and do it if you're doing this for like an engineering firm. But for us, it's the way we do it just because it's easier and faster. If we need someone to make something, we can tell them how many they're going to make and kind of lay out the whole task on the drawing for them. So these notes are for our sponsor, Solarcraft. So this was a sheet metal part that our sponsor made for us. So we tell them how many are made, so then they know when they come off the laser, they can find the different parts and get them all collected, count them, make sure they have enough. We can tell them all of the bends are 90 degrees, so they know how far to bend all of the parts. This is a sheet metal part, so all of this, it starts flat, and there's 2 different bends in this part that they have to bend. So they know how far the angle should be, so they know these are 90, which is really easy for them to do. This part we'll talk more when we get specifically into sheet metal, but basically it's asymmetrical. When this part is flat, there's 2 different ways to make this. You can make this with, you could kind of imagine if this bend here went the other way, and if this bend here went the other way, the part would be the mirror image of itself. So a lot of times we'll just give them the single drawing and the single part, and we'll tell them to mirror it if we want the opposite mirrored version of the part as well. So if we have things that are on like the left and right side of the robot, that's how we'll normally do it. So in this case, we tell them kind of almost twice here that we're making 10, 5 are mirrored, half are mirrored, so that they know kind of when to bend. So those are some of the notes we'll give them. If it's a part that we're making in-house, but just another person is making it, we'll tell them the quantity, what tool, what material, all of that stuff goes somewhere on the sheet in some way. So they have the instructions they need to be able to fully make the part. Okay, so we're going to look at several of these example parts. These are some of the tasks that we're going to have everyone work on as well. Largely, it's just so we can understand how the dimensions work and how we can take these views and actually make a 3D model from it. So we have these different views of the part and all of the dimensions. So you should have enough information to make the part accurately for all of these that will be provided. But you have to go through and understand how the dimensions work and how to get to this final model that's dimensioned accurately and everything works. So let's look at some of the specifics of these drawings and what it's actually trying to tell us. So we start by dimensions. So these are one of the most useful parts of the drawing. They help us accurately know the size of the part and also the locations of a lot of the features. So we have here all of the dimensions in this box, in this blue box, are length. We're assuming for this part, it's fine to do it in inches. These parts are probably actually modeled in millimeters, but it doesn't really matter for us. We're not trying to produce these in any real way. So it's fine if you do them in inches. It's fine if you do them in millimeters. The part will be the same. It'll just be scaled, right? It'll just be bigger or smaller. Most of the time for our parts, when we actually produce them for the team, you always assume inches unless it's called out and explicitly said something else. Almost all of our things are designed in inches. So this part right here, there's a few different length dimensions inside of here. You have the dimension line, and it has extension lines that go down and tell you what it's dimensioning. So this 114 dimension is dimensioning between the two centers of these holes. So it can kind of looks a little odd because all the dark lines, the full lines, are lines that you'd actually see in the part itself. So you can look, if you're looking at this from the top down, you can see you'd have like this line here represents this line right there. So you can see what you could see, or you could see how that would work. But you also have these like dashed lines, and those wouldn't actually be there, right? That's just a hole. Those dashed lines aren't real. Those dashed lines are there so you can see where the center of the hole is. So that's just the hole call out. And so any of the dashed lines are going to be kind of hidden and not necessarily part of the, it's not a part that you'd actually be able to see. They do it again in a couple different places. Some of them share extension lines. So you have this 13 here. So it's telling us the thickness between these two sides of the part, or these two edges of the part. And then the 38 is between these two lines. So it's kind of the width of this segment of the part. And then you have another 13 here. So we're getting some more information about the size of the part and those different features of it. We also have two different ways to dimension round elements. So any hole that's like a full hole, or really as long as it's more than about 180 degrees or so, we always call out with diameter. So this little symbol right there, the circle with the line through it, is your diameter symbol. So this is telling us that the length all the way across the circle is 22. In this case, we're assuming inches, so 22 inches. So this is a really big part, but if it was millimeters, it'd be a lot smaller. You also have radius. So for parts that are 180 degrees or less, we dimension with radius. So this is telling us how big this rounded section is. So basically from this center point out to the edge of this rounded part of the part is 32, where if we were doing it diameter, we'd have to double it, right? So from the edge of here all the way out to there, we would have 64 because you have two radiuses in each diameter. Okay. This view is also a little bit different. So this doesn't just have our normal front, top, side view, where the side view normally would be, it has this thing called section. And so that is a section view. So there's times where just having one of the projected views doesn't actually provide you with enough information because there's something happening like inside of the part, or some part feature of the part would be blocking that view. So if we just had the side view, you would have you'd have a line right about here, right? It would draw through, and then you would just have the line at the top, and that would be all you would see. So if we want to actually see the detail of this sort of ramp section, we need to have this. We need to have a section view. So this line right here, this A line, is depicting where we're sectioning the part, and then it's basically just like if we cut this in half, and then we started looking at the side view after we had cut it in half. So that lets us see this this ramp section, and it lets us see this little section up here to be able to get how wide that part is. So you may see this in a couple other parts of the assignments where we have this section view so you can see the inside details of the part. Looking at this as well, we see a couple different dimension views. So all of these lines are dimensioning from this same base plane. So we can see that this is 13 up to this bottom point here. This is 19 up to this bottom point, or to this face up here. And then it's 64 to the top of the part. Another thing you may have noticed is there's these dashed lines inside of this part. So this is another way that we can see inside of a part without doing a section view. So if we didn't want to do a whole nother section view, but we still want to see partly where these holes are located, we have these hidden lines in here. So this dash line down the middle is still our center line. So it's kind of like the center line of our hole going through. And then we have these thicker dash lines, or these longer dash lines on the outside, which are hidden lines for the hole on the inside. So basically they're saying you can't actually see this from the front, but it's a part of the part that's on the inside. So you can just have more context to how the entire part is made. In general, we try to avoid dimensioning to those parts. So you wouldn't want to do a, you wouldn't want to like call out the diameter here based on the width of these two hidden lines. You would definitely want to do it here like it's done to show the diameter when it's on an actual viewed line. But the hidden lines are very useful for times where we're trying to provide more information about the part, and so you have a better idea of what it actually looks like, and when you're recreating it kind of in your head and in the model, you're able to do so a little bit better. Okay, so we're going to make this part together in Onshape. I need to figure out, let me pull it out so I can reference it separately. Give me just a second. Okay. We're going to flip over to Onshape. We're going to create a new document. Feel free to follow along on your computers if you would like. These will be, one of the assignments is to make these parts later. So if you do these right now, you'll be a little bit ahead. If not, you can feel free to do them in a little bit. All right. Okay. So in Onshape, we have our part studio, so we can start making a part. One of the things we have to do is we have to think about how we want to start our sketches. There's almost always multiple ways to make the same part. So we don't always have to be, you don't always have to do it the same as someone else. In general, you want to have relatively few features. You don't want to necessarily have the fewest features all the time. Sometimes that can lead to a more difficult part to model or modify in the future. So a lot of times you have to think about how it might change. What do we actually want to provide in each sketch and each feature to where they make sense together. For this challenge, doing them in as few features as possible is probably useful. It helps you get out of the habit of just doing every different part of the thing or different part of the drawing or part or feature that you're making as its own sketch and feature. Like that just takes a lot of time. So if you can combine things into multiple, into single sketches, um, and use it that way, it saves you a little bit of time. So the first thing we're going to do here is we're going to make a sketch. I'm going to do it on the top plane for this one. I'm going to hide our planes. I don't need to see them right now. Let me see if I can. Okay, let's see what I want to do. Okay, I was trying to figure out if there's a better way to screen share this, but I think we'll do it this way, and I'll just flip back and forth as we go. Okay. All right. Okay. Okay, so we're gonna basically draw the we're gonna draw a portion of this top view first to get us started. So we're in this sketch now. So we can draw there's a few different ways we could do this if we wanted to. The simplest way here is probably to draw a center point rectangle. So we can put the center of this part as our origin. And then we're going to look at figuring out some of our dimensions. So we know, I think there's a bigger set. There we go. So this is a little bit easier to see. So we know that we talked about earlier, the radius of this whole rounded section is 32. So that actually tells us the width of this part, because we know that this is, since it's not marked anywhere, we can assume these are tangent, which means like this circle is basically 180 degrees. So the whole length here is 64. And then we'll have to figure out the width as well from the information that's provided. So a lot of times you're not necessarily given all of the information you need for every sketch along the way. It's provided, but it's not necessarily provided explicitly. You have to understand it from the information that is provided. So in this case, we're looking to dimension this line to 64. I'm going to zoom out because we're just making a very big part. Okay. And then we're going to dimension this line as well, and we can figure out how wide this entire part is by knowing that the radius here is 32. So we know we're 32 from this point to this edge. We know we're 32 from this point to this edge, and we're 114 in the middle. So we can do 32 plus 114 plus 32, and we'll get our entire length that way. Dimension 32 plus 32 plus 114. I did that right? Yep, it's 114. Okay. So yeah, so in Onshape, you can definitely just do the equations right there. You don't have to do the math in your head or calculator or anything. It'll just take it in right as a number. It's also useful because it keeps it there. So you can actually go in, if you did mess up, mistype, maybe type 112 here or something, you can just go and edit that one number without having to try to figure it out. All right, so we have part of our rectangle. We can draw our larger, we can draw our two circles now if we want. That's a reasonable next step. We're going to put them along our midpoint line somewhere. And then we know some things about them, right? So we know they are 32 from this far edge, and we know that they are 22 in diameter. So we can go ahead and make them 22. You could make the other one 22 if you want. You can also click on both of them and make them equal. So now they're both equal to 22 since they're equal to each other. And we can also dimension from here to here and make that 32. Same thing over here. There are other ways you could do this. You could mirror this circle if you wanted to. You could do a variety of different features to get the same part. This is just one way to do it. Let's see. So we have that portion. We need we can make some of the other ones. So we'll probably end up making these. These are different features, but in Onshape you can keep using the same sketch, so we can do things a little bit differently than we did in some of our other CAD programs. So here I can actually just make. That's weird. Did I not? Why is that weird? Oh no, that's fine. Okay. All right. So we have this rectangle. We need to know how wide it is. So it's 13 plus 38 plus 13 wide. So we're just gonna do the whole thing here first. So again, we can come up to our dimension tool. We can have this one going the other way. 13 plus 38 plus 13. So we've used basically all of our dimensions from here, but we haven't done those radiuses yet. So we can deal with them as sketch fillets. We can tell it how big they are. I think we can do it. Oh, no. Okay, you have to click them each time. One more. All right. So now we have that sketch fillet. We've told them they're all 32, and it took all of that, so we're good there. Okay, so yeah, so now we have most of our sketch. Why is this? Oh, I made it construction on accident. That's a different problem. Okay. Okay, that was my fault. We do not need those to be construction. Those can be real lines, and we'll figure that out in just a second. Okay, so we have most of a sketch. This looks mostly like what this looks like. This inner part isn't drawn yet. We're going to do that as a another feature a little bit later. So we can go ahead and we can extrude this part, so we know we're going to add some thickness to it. We're going to extrude the whole thing up to this 19 dimension. We're going to tell it it's the 19 dimension thick first. So to do that, we're just going to click extrude. We're going to select it actually auto selected all the part that we wanted it to. And for our depth, we're going to tell it 19. So then once we hit check, we have a portion of this entire part. So now we have to look at making the rest of it. So we're going to add all of this, like this block part that's up at the top. We're going to add all of that part. So we're going to extrude that up, and we're going to extrude it up just as a full square, and then we'll come in afterwards and we'll make this angled part. So one of the useful things is we already have this sketch done in Onshape already, and we're allowed to use that again. So we can just click extrude. We can tell it which face we want. Maybe I can tell it which face I want. It's not letting me tell it what face I want. There it goes. So we can select it right there. So I just went down to the bottom, selected the face of that sketch. So we have that inner rectangle that we already drew. and we're going to be able question. Give me 1 second. Okay, so we're going to be able to tell it how tall to make that. So we're going to make it 64. So in here, we're going to do blind, and we're going to tell it to be 64 tall because we're going all the way up from the bottom. We're there. Okay, we had a question in the sketch. How do we tell it to be 32 away? So for that, to make this to make the circles 32 from away, yeah, so all you do is you just dimension it. So this dimension right here is what's telling it that this center point is 32 from the edge. Since we drew it kind of on the line already, it knew that it was horizontal to this center of this rectangle on this other side. So if we have this dimension, if this dimension doesn't exist, so if I click on this and delete it, I could then move this in and out. Once you actually put the radius there, it'll force that dimension, but it gets a little angry at you for other things that we've done. So if I don't do that, we should be able to come back in and dimension it again and still be happy, I think. Sometimes the order of operations is a little tricky. Let's see, 32. Yeah, so it's still happy there. And that works well enough. It moved the dimension kind of the opposite side of where the circle would be. So it's a little weird with this dimension line, but it's still doing the same thing since we dimensioned it to this arc. Okay, so now we have the majority of this drawing made. And we're just now trying to figure out how do we make this angled piece. So there are multiple ways to do this. The easiest one is not necessarily the most intuitive way to do it. But if you look here, and this art can kind of show you, kind of gives you an example of how to do it, because we want to cut away this section so we can actually use a revolution cut or a revolve cut to remove this material, and it's a little bit quicker than trying to figure out the best way to draw on the inside of one of these planes. Like we can make a plane that's the right distance away. We could then make a sketch of this triangle right here. We could cut it out, and that would all work. But we can avoid that extra plane by doing it with the revolve cut, which I'm going to show you how to do right now. So we can look at the top of this part. We can look at it coming down. So we have this same, the kind of view that's right here. And we're basically going to draw a rectangle that's a little bit bigger than the entire part that is on the inside, this inside portion that we haven't really drawn yet at all. So I'm going to make a new sketch up here on the top. And I'm going to make a new rectangle that's going to come out all the way past it because we're going to use it to cut through the part. So it's okay that it's going outside of it. And then we have to do some dimensions. So we have to tell it how big this wall is here. We have to tell it how big this wall is here and how big this wall is back there. So we know these are both 13 from this dimension here. And we know this is also 13 from this little dimension down there. We know the kind of the depth of this wall right here. So I'm going to go ahead and do that with our dimension tool again. We just click on a line, click on both lines, drag it down 13. Do the same thing to the other side. And one more time up here. All right, so now that's dimensioned. We don't have a length here, so this is still blue. So if you really wanted to, you could come in and you could dimension this if we want. It doesn't really matter what that is, but it will stop it from somebody like moving it in the sketch and then it messes up our cut or something. So we can keep it dimensioned. And then, so instead of doing an extrude, we're going to do a revolve. So we're going to click revolve. It asks what our axis is, and we're going to choose this line right here. And that's definitely not what we want the part to look like, right? That's a little silly. So we're going to go into remove. So we're going to like remove some of the material. We don't want to remove all the material. That's a lot of material. So instead of full, we're going to tell it one direction. It's going the wrong way, right? It's trying to remove material from the air. We don't want that. We're going to flip it with this little opposite direction button. And now you can see that's starting to give us something close to the part that we actually want. But we need this dimension right here, this 45 degrees, because it's only marked at 30 right now. We're going to change that to 45. And now once we hit accept, we should have the part we were looking for. We can double check some things if we want. So there's one dimension that we never actually used. We didn't use this height dimension right here, this 13. So we can go in and see if that is actually true. So we can click our little measure tool, click that line to this bottom, and we get 13 there. So we know we did it right. So now we have our finished part, and it meets all of the dimensions from our drawing. Okay, so that's one of them. If we keep going, we can look at a couple other parts. So this was model 2 from the assignment, and so this has a little bit more. This has a little bit more features to it, but we can still create this pretty easily. There are multiple ways to do this. Again, to get the same output, some of them are similar, some of them are different. Let's see what we're looking at. Oh yeah, so there's one more thing that's added into this part that wasn't added into the previous part. Right down here, we have this extra dimension. So like I said, we normally only want to give exactly enough information to create it. If you start giving, if you start dimensioning things in multiple places, you're actually providing too much information. You over-define your drawing. So dimensions written in parentheses like this 102 is, are what are known as reference dimensions. So they're not necessarily, they're not specific for the person making it to actually get that dimension right? We haven't talked about tolerances things yet, which is how like how close something should be made to the right number. But in this part, if you had all of these dimensions, we don't know which one is a critical dimension and which one isn't. Like which one should we actually be worried about the size being exactly right compared to the others. So the reference dimension is just there to give you like extra information. It might help you. It basically, in this case, all it does is help you not have to add up these three numbers, and you just can look at the sheet and see what it is. So if you were going to produce this out of like a block of material, you could know how big of a block do I need? Okay, I need something that's at least 102 long, and you wouldn't have to do the math really fast to add those up. You could dimension these in a different way in this drawing to make this 102 matter more. So instead of having 22, 58, 22, you could dimension these all off of like a base dimension over here, and you could do 22, then you could dimension this instead of from this point being 58, you could dimension it all the way from here being 80, and then you could have this 102 over here. And now that means something slightly different when they are going to produce it. Most of the times in our cases, it doesn't really matter which way you mention things. There are some very specific parts where it will, but we'll learn more about that later. As long as you provide enough information to make the part, most of the time we're okay when we're doing most of our parts. And we'll learn more about that, and you'll get it more as you get experience doing it as well. Okay, so we're gonna go ahead and look at modeling this part as well together. I haven't actually done this one in Onshape, so we'll see how this goes. This will be my first time doing it. We're gonna make a new part studio for it, just so we're to have a clean slate. Looking at this, we got to figure out which way, how do we want to start, right? We have to think about, okay, what is the feature that makes the most sense for us to CAD first? What like are our extrusions going to be, and then how do we do the cuts? And I haven't done this one in a while, so this is actually a little tricky. Let's see. We can choose a host of different ways to do it. Right, because you can imagine you could make a rectangle that's just completely as big as this whole part is, and you could cut out every little segment of it if you wanted. You could make some part of it you could make like this portion here as a sketch, and then you could make this rectangle as a sketch, and then you could make these back triangles as a sketch. So there's a variety of ways to do it. I do think yeah, so the way I think I would approach it from this like 30 seconds of thinking about it is we're gonna make this portion right here. So this side portion, we're gonna extrude that all the way back, and then we'll add in the other features we need up on top of it. So that means we're gonna start from the side. So I'm gonna make a new sketch over here on the right side. Going to hide our planes again. All right, so this is 32 tall, 70 long, and it has a 22 long little ramp section that is 13 from the bottom down here. So we can use these 3 dimensions and this dimension right here to give us all the information we need to kind of draw this profile. So again, there's a variety of ways we could do it. You could do, you could have a rectangle and you could cut out the other little bit. You could also draw all the line segments. I think for this, we're just going to make it I'm just going to draw a rectangle real fast. I'm going to dimension it to 70 and 32. Get our dimension tool, 70, zoom out, zoom way out. All right. And what did I say? I said it was 32. Yep. So you have those dimensions. And then I'm going to draw in a line that's just going to do that. And then we're going to add in the dimensions for this. So we know this is 22 from this edge to here, and we know it's 13 up. So we're going to add in those dimensions. Get 13 and 22. All right, I can drag that down and make it look a little bit more easy. So this inside rectangle right here is what we're going to extrude. We can select it beforehand, so we're only selecting that shape. These other lines out there in Onshape don't bother us at all. They can just stay there. And we're going to make it this whole length, which is that 102 reference dimension that we have down there. So we're going to make that 102. And now we have part of our like base part. So that got quite a bit of our geometry. We have both of our little like kind of the side pods that are over there. And then we need to add in our we need to add in this kind of top section, so then we can take out the ramp from it. And there's a few different ways we can do that. So this is going to be a little bit opposite of the way we just did. Since the last one, we had that angle dimension already. This one, we don't have that. So we'll make the, we'll go ahead and actually just cut out this from another sketch when we get to that point. Okay, so what do we need to know right now? So we're going to make a rectangle that extrudes up to this 75 dimension. So we're going to make this whole upper section that will eventually cut out that little bit. So just like kind of what we did before, we're going to draw on the bottom. We're going to make a new sketch, and we'll just put a rectangle in. It's a little bit trickier. We don't have a midpoint in the middle of our part anymore, so we didn't start with a center rectangle. So we do have to do a little bit more dimensioning here. So we know it is 58 wide, and we know it's 22 from an edge. So we can add in those dimensions pretty easily. Come back up to the dimension tool, make it 58, and it's 22 from one of the edges. So all of our lines are black, which means it's fully defined. We don't need to add in the 22 from this other side because that's known since we already know the full width of this in the CAD program. So now we have this rectangle, and we're going to extrude it up this 75 dimension. So we can do that right now. One, go all the way to 75. Oop, that's going the wrong way. So we use our direction change, push that going up the top. Okay. We can make our little triangles that are back here on the back. We know we have enough information to know what those look like, and those are really quick to draw. So we're going to draw those in real fast. Those are just lines coming down like that. It filled it in for us. We do the same thing over on this other side. And then we should be able to just click on them, nice and quick. And then we just have to know how wide they are, and that dimension's up here. So we can look at it when we're looking at the top. This 13 right here is telling us how deep those little triangle side pods are. So we can extrude those to 13. Again, they're going the wrong way, so we're going to flip those around. I think, yeah, so that's important too. So if you do these as new, they would make their own parts here. Instead of being a part of this assembly, they would be their own parts. So you want to make sure that if you're adding something to an already existing part, you make sure this add is selected. Then we go ahead and hit check. And so now it's all a single part down here. It's still labeled part 1. And we're pretty close to the portion we need. Okay, so the last little bit is a little bit trickier. So we have this hidden line in here that can kind of show what this looks like. So we know it's the same bottom point down here. We know it's the top point up here at 13. And we want to remove all this middle section. So there's a few ways we can do that. So the most useful is we're going to create a plane. So we're going to use the plane tool because we basically want to sketch almost inside of this block, right? And that's a little tricky to do. That one. So you have to tell it how you want to create a plane. So there's a few different ways you can make planes. One of those ways is plane and point. So I selected the midpoint of this line. So this gives me like, we know it's going to go directly down the middle of our part. And I want it to be parallel to the side face, right? So this is kind of where I want the sketch to be. And it shows you the plane so you can know if you're right. So if you happen to have clicked the wrong thing, it wouldn't work. So instead, if I have that point clicked and I clicked here, now I would just have this face. That's not really what I want. You could click on some other one to get a different face, and you may not want that either. So instead, I'm going to click over on the side one, and this is the plane I want to sketch on. So I'm going to go ahead and hit check. I can select that plane and click the sketch button. And so now I have the ability to kind of sketch right in the middle of my part. And so to do that, what do I want to do? I want to do this a little bit easier. So all of these features out here aren't they're not matched in where my plane is. So I can click on these 2 points though, because these are the 2 points I'm going to want to connect. I can right click. Oh, maybe I can't right click. Why can't I right click? Hold on. I can right click there. Can I not do it on the point? Okay. So I'm going to do it on the lines then, because I can't quite do it on the point. So I'm just going to do, I can do it on one line. And this is where I'm still learning Onshape. So you can do use there. So that draws our line. Now we have that point. We can't do it on that one, but we should be able to do it on this one. We can do use there. All right. So now we have the points that are going to be connected for us, and that's the important part. So this point here is the right one down to there. So that gives us kind of the line that we want. That's the same as this dash line right here. So this dash line is showing that it's hidden, and it's just that ramp connecting them all the way down. And we already know that these dimensions are right because we already had that 13 dimension that we pulled kind of from that side pod, and we had the dimension up front here that we pulled from this line. So we know those are in the right spot. I'm going to go ahead and finish out this drawing. So we have that triangle made. So now we know where it is, and we can extrude from this shape. So Onshape was smart enough to figure out what I was selecting. It knew I wanted this closed feature, so that closed triangle I made. We're going to tell it it's symmetric because we want it to cut both directions. We don't just want it to cut in one direction. So we're going to go to remove to make sure we're cutting material away. And we have to tell it how thick it is, and it is 32 thick from this dimension here in this shape. So if I do 32, it shows us that we've cut that triangle out, and it gives us a nice preview. And we can click the check mark. And then if we don't want to see that plane anymore, we can hide it over in our feature tree. And so this should look like, if I click on this button, we can get our isometric view. This should look basically exactly like that there. It's not actually isometric. It's one of the weird things. Okay, so if we click our isometric, we can tell it to be isometric. So you can tell it has a bunch of different view options. Isometric is one of them. And so now that should look exactly like this part up here. So we have completed the part. All right, so going forward, in the Google Classroom, I've already done assignments and I've kind of split it out. So basically there's a big list of parts to make. So the first two we did together. There's about 20 in total. So I've divided them out to be about 5 every week or so as the timeline. If you want to do them all really fast, that's great. However you want to divvy them up. But the idea is that you just get used to understanding how some of these drawings work. They get more complex as we go a little bit. You'll probably need to ask some questions. That's kind of the point. Some of the stuff we may not have gone over specifically on how to do things. You may have to investigate. Okay, someone asked how we move the triangles. I can back up and show that again. So let me delete this. So once you have the sketch and you have that triangle, we just use the extrude feature, and it will automatically kind of select the closed in feature. And once you have it, if you have the sketch selected, and then it's symmetric, you make sure to select remove, and we tell it its dimension, which was 32, right? Yep, 32. Okay, so then we type in 32, and it shows it that it's being removed there under the remove tab. Okay, so yeah, so you'll be able to complete those and then submit screenshots to our Google Classroom to do it. For students on other teams, feel free to just do them. I won't be grading yours. But yeah, the basic goal here is so that you're learning how to read the drawings and interpret how these drawings and shape works, help with some of your spatial reasoning, because a lot of this is how you kind of make a mental image of it in your head and kind of choose how to approach something. So there's some problem solving, some spatial reasoning, and getting better at all of the Onshape features and things so that we can make more robot specific parts as we go once we know how all these features work. Um, okay, backing up a little bit. So the triangles on the side, we did on a sketch on the back. So we just made a sketch on the back that was just these lines here, but if you draw them properly, Onshape will do it for you and kind of understand that that shape can be closed off. If for some reason it's not, you can draw out the full triangles, and then you just do extrude with the add button, and it adds them in to the right spot. And if they're going the wrong direction, we can flip them around to be in the right direction. Okay, so yeah, so that's basically our assignment for a little while. We'll have those going. We'll have some other things as well, but that just gives you a task you can be working on for the next few weeks if you're not sure what to be doing. In the back of this presentation, there's also some more further learning. If you do want to learn how to start creating your own drawings, Onshape has a lot of great resources for that. That's going to walk you through it better than I will. I highly recommend that. If you want to go even deeper in how engineering drawings work, and want some more advanced stuff, this is a really cool video. It definitely goes into some more advanced topics than we do, but I recommend it. And then there's some more stuff on how some tips and tricks for doing engineering drawings and things from one of the universities as well.